Welcome back to the Deep Dive. Our mission here, as always, is to take a huge pile of research and, well, really complex ideas and boil them down into what you actually need to know.
Exactly. And today, we're tackling maybe the most complex machine on the planet.
The human body. We've got this amazing educational guide that really breaks down all the major parts and what they do.
But this isn't just about naming bones.
No, not at all. This is about the engineering. Our goal for you is to really get how even the most basic things like thinking or, just breathing are controlled. We're looking for the surprises, the efficiency of it all.
Right. We want you to see the complexity that's hidden in plain sight so you can walk away with a really solid understanding and fast.
You bet.
Let's get into it. Where should we start?
Let's start at the top, the command center, the head and the brain. It's this, 3-pound universe that runs the whole show.
It absolutely is. And the brain's role is just massive. Our source material really highlights four main jobs. It
Yeah.
controls our thoughts, for one. It manages all our memories, both long and short term. It processes our emotions, which is a huge task. And of course, it directs every single movement we make.
Conscious and unconscious movement,
And
you think?
what's amazing is how it can juggle all of that, abstract thought and just keeping you from falling over without crashing.
And the rest of the head is like this advanced sensor array, constantly feeding the brain data.
Exactly. You've got the eyes giving you vision, the nose for breathing, and of course, smell. The mouth, the teeth, the tongue, they're for fuel and for communication, for speech.
But you said we're looking for surprising efficiencies. The ears, you mentioned something there.
Yes. Okay, so the ears. Everyone thinks of hearing, right? Processing sound waves.
Sure.
But the guide really emphasizes their second job, a non-acoustic job. Inside your inner ear, you have this incredibly complex system that's all about balance,
So it's telling the brain where you are in space.
constantly. It's sending spatial orientation data nonstop. So it's not just a microphone, it's also a gyroscope, an accelerometer built right into your skull.
Wow. Okay, so if the head is this heavy, complex control center, it needs a pretty serious connection to the rest of the body,
A very robust, but also very flexible connection.
which brings us down to the neck. Something we probably don't think about much until we sleep on it wrong.
We really don't. But from an engineering standpoint, it's a huge challenge. Its first job is just structural support. I mean, it's holding up a 10 or 12-pound head.
And letting it turn left and right. That's a huge range of motion for something holding that much weight.
It is. It requires this sophisticated stack of vertebrae and muscles to stabilize a heavy object while also allowing all that movement.
But that's only half of it, right? The guide says it's also like a main highway.
It's the primary infrastructure corridor, yeah. All the high-value traffic passes through it. You have the windpipe for air, the food pipe for fuel.
And the really critical stuff, the blood flow to the brain.
That's the one. The major arteries and veins carrying oxygenated blood to the brain and waste away from it. Without the neck protecting that corridor, the brain would shut down in seconds.
So it's a lifeline.
It's the lifeline, the support column, and the data cable, the spinal cord, all in one vulnerable package.
Okay, so following that flow of resources, we get to the engine room, the chest.
Right.
This whole area is basically life support and protection. The ribs are like a shield for the most important organs.
And here we shift from, control and sensors to pure life maintenance. Circulation and respiration, they are completely linked.
Let's start with the heart. We call it a workhorse, but how does it keep going? That's the interesting part. Its job is to pump blood everywhere, nonstop.
For 80, maybe 90 years.
How is that even possible?
Well, the guide points to a few things. The tissue itself, the cardiac muscle, is incredibly resistant to fatigue, much more than, say, the muscles in your arms or legs.
It runs on its own, right?
It does. It has its own internal pacemaker, an electrical signal generator, so it just keeps that perfect rhythm going, maintaining pressure throughout the whole system, all without you ever having to think about it.
And right next to that pump are the lungs.
The other half of the equation, they manage the gas exchange. You breathe in, they take the oxygen.
But the real work is happening on a microscopic level.
Oh, absolutely. Deep inside in these tiny sacs called alveoli, that's where oxygen is swapped for carbon dioxide, all based on simple pressure differences.
So the chest really is the core of it all. It's where the pressure is made and where the air is traded. It's the life support machinery.
All armored behind that rib cage.
Okay. So air and blood are circulating. The next step has to be fuel, resources. That takes us down to the abdomen, which the guide kind of treats like a processing plant.
A highly advanced one. It's all chemistry and filtration down there. It starts with the stomach, of course, using acid to break down food. But the real magic is in the other organs.
Like the liver. I think most of us just associate it with, processing a big meal.
It does that, but our source highlights its incredible duality. It's doing two massive jobs at once. First, detoxification. It's the body's main filter, cleaning the blood. And at the same time, it's helping digestion by producing bile, which is essential for breaking down and absorbing fats.
So it's a filter and a digestive aid.
Simultaneously. It's amazing. And right after that, you have the small intestine, which is just built for one thing, absorbing nutrients. It's all folded up to maximize surface area.
And then the large intestine kind of takes what's left.
Yep. It absorbs the last bit of water and forms the waste. But then you have this other specialized filtration system, the kidneys.
Right, for liquid waste.
It's more than just waste removal. Their deeper function is regulation. They use millions of tiny filters to control the exact volume and chemical makeup of your blood.
They're balancing things.
Perfectly. Electrolytes, fluid levels. Without that precise control, your nerves wouldn't fire correctly. Your heart would fail. So the abdomen is intake, extraction, and this incredibly complex chemical and fluid regulation.
That's incredibly comprehensive. Okay, so we've done the central trunk. Now we need to look at how this machine actually moves and interacts with the world.
The limbs are tools for mobility and interaction.
Let's talk arms and hands first.
The upper body is all about leverage and dexterity. The arm, the shoulder, elbow, wrist, it's designed to let us lift, hold, and work with a huge range of motion.
And then you get to the hands, which are just another level of refinement.
Absolutely. Our fingers, and especially our opposable thumbs, give us that fine motor control. For writing, for using tools, for everything we do, it's backed up by this incredible density of nerves for sensation and control.
And then the legs and feet are built for something else entirely.
Power and stability. The thighs, knees, ankles, they're all designed to bear the body's entire weight, to let us stand, walk, run. It's strength over finesse when you compare them to the arms.
And here's another one of those surprising details like the ear, the feet, specifically the toes.
Yes, they're not just there. Just as the inner ear gives you that high-level sense of balance, your toes are making constant micro-corrections when you walk.
So they're helping you stay upright.
Constantly. Adjusting your weight, reacting to uneven ground, it's happening all the time, completely silently.
That constant silent correction is a good transition, actually. We've talked about all these parts, but none of them work in a vacuum.
No, you need the underlying infrastructure, the systems that connect and control everything.
The skeletal and the nervous systems.
Exactly. Let's start with the framework, the skeleton.
And the key number from the guide is 206.
206 bones, and you have to think of them as a collection of levers, pivots, and shields. They give the body its shape, they protect the organs we talked about, and they anchor the muscles that let us move.
Without them, we'd just be a
blob. A completely inert blob. They are the absolute requirement for structure and movement, and they're constantly remodeling themselves based on the stress you put on them.
So if the skeleton is the frame, the nervous system has to be the wiring, the high-speed network.
I like that analogy. It's a fiber optic network, and it controls absolutely everything, every single activity, conscious or not.
And that's the brain, the spinal cord, and then all the nerves branching out.
That's the system. It's a real-time communication highway. Its only job is to send messages from the brain out to every single muscle and organ and then relay messages back again.
And it is incredibly fast.
Astonishingly fast. Some of these nerve impulses travel at over 200 miles per hour. That's what gives you your reaction time.
The ability to pull your hand from a hot stove before you even really register the pain.
Precisely. It's a constant, nonstop chatter that keeps the entire machine running and updated.
So, to sort of wrap this all up, what this deep dive really shows is that the human body is just. It's a masterpiece of engineering. Every single part works together.
Seamlessly. To keep us alive, to keep us healthy.
And for you, the listener, we hope that understanding some of these details, that your 206 bones are under constant high-speed control, the organs are multitasking, helps you appreciate it.
And maybe take better care of this machine you're living in.
So let's leave you with a final thought to chew on, something that really builds on this idea of coordination.
We established that the 206 bones provide your structure and the nervous system controls everything instantly. So just consider this. Right now, as you're sitting or standing, your brain is sending a continuous stream of minor adjustment signals to your muscles just to counteract gravity.
just to keep you balanced.
Just to stop you from tipping over. So what is the true hidden cost? The constant energy demand of that sheer volume of silent, instantaneous messages being sent every single second between your brain and those 206 structures. It's an unseen, continuous biological labor.